So we are going to continue the previous session, that is in the previous session we have the reduce phase. We discussed about the map phase and reduce phase. Now we are continuing that. So the mapper is giving the output locations, intermediate output locations to the job tracker. And what is the job tracker? How it is helpful, that we are going to discuss now. Job tracker and a task tracker. Here it is the distributed environment, distributed processing, meaning the different machines will be there. So in all the machines we have to install a small software which is capable to execute a process. The process may be the mapper or reducer. These are the two basic operations in the map reduce. So the task tracker can execute either mapper or reducer. So in all the machines except one machine we have to install the task tracker. So task tracker is a process that is placed on the different machines in the cluster, and all the machines except one consists of the task trackers, and that one mission will have the job tracker. And what is the task tracker? The task tracker can handle either mapper or reducer, and the job tracker, it is the master process which can control these task trackers, meaning that it can instruct and it can perform the operations, and what operations are performing in the task trackers, everything that will be taken care by the job tracker. So these are the task tracker and job trackers. These two are the major process control environments in the map reduce concept. So and then it handles all the task trackers, that is the thing. And now map reduce workflow, how it is executing the entire process. That is, we have the user application, we have the map reduce user application. That user application is having the map reduce library. That map reduce library is having the capability to access with the cluster, and in that the first task for the map reduce library is it has to split the data into different splits. So each split, the splits will be designed. After that, the map reduce library, it can copy the process, required process application to all the places where the application has to be executed. That is, the map reduce library will decide how many number of mappers required, that is based on the number of splits, and how many number of reducers required, that is based on the user requirement. The user will specify how many outputs are required, those many number of reducers are required, so that it will create two reducer processes and one master process. This master process will be placed on the master machine. So it will copy all the entire application to all these machines where they have to place, and then it will hand over the control to the master, and the master will process and control all the processes from here onwards, and that is the master, and these two are the workers. There are two types of workers available. One is the mapper and another one is the reducer. And the mappers and reducers, now the master will inform the workers, that is mapper workers, to start their work whenever it is ready, so that the mappers, they will take the input from the corresponding splits and they will produce the intermediate outputs separately, so that here the split 1 is processed by the mapper 1 and it is producing the intermediate output 1, and here there are two outputs are required. So the intermediate output will be divided into two regions, and the mapper 2 is also producing the intermediate output 2, and it is also divided into two regions, and that output, the third output, is also divided into two regions. How many number of reducers are there? Those many regions will be divided. And this process is called the partitioning concept, partitioning of the intermediate output into different regions. That is the partitioning, where it will be performed. This entire process will be performed in the local storage where the mapper is executing. And whenever it is completed, the mappers, they will send the locations where the region 1, region 2 are available. They will be given to the master process, and then the master will instruct the workers, reducer workers, to start their work, so that the reducers will take the locations of the intermediate regions from the master, because they have taken from the mappers, individual mappers, and the reducers, they will directly take the output from the corresponding regions. Reducer 1 will take the input from the region 1, and reducer 2 will take the input from the region 2, and they will produce the outputs. Okay, so that is the output data. When the output data is generated, that will be informed to the master, and the master will inform to the user application that your process is completed and the output is generated. So see here, now it is the responsibility of the user to collect the data where it was given. Initially, whenever the application is started, the user application has to mention where the output data has to be stored as the part of the calling of that application. So it will go and collect the output data where it is available. So now let us discuss what is the placement of these components, where we can place these components. Here we have seen that there is the input, there is the output, there is a mapper, reducer, master, all these are available. Now anyway, the user application is on the client machine. Now where the other components are placed? See here, first of all, the input is placed on the file system. Some file system will be there. In our case, we are using the HDFS. Not only HDFS, you can use the local file system or S3 or any other distributed file system. And the output is also stored on, will be also stored on the file system. And now the master process, it will be placed on one machine. You can see that the green color box represents the physical machine. So the master process will be placed on one machine, that is the master machine, that is having the job tracker. Okay, and the task tracker can be installed on other machines, so that see here you can observe that this is one task tracker. Let us assume that we are having the cluster of 5 machines. For 5 machines we need the map. For master, one machine is over. Now we have 1, 2, 3 mappers and 2 reducers. So we need 5, still we need 5, but we have only 4. Because of that reason, one machine can handle 2 mappers, that is one task tracker can handle 2 mappers, and then the reducers they may place on the 2 other machines. So that this is the placement of the map reduce components. So for the job tracker or master, we can have one machine, and task trackers, we are having 4 task trackers. They can share the resources and they will be executing all the given processes, and they will produce the output again on the output, that is in the file system. Now how can we place this how can we place this MapReduce on the HDFS cluster? HDFS is the cluster and MapReduce is also the cluster. So in that, in the HDFS, name node and data nodes are the machines, major machines. Name node is the master and data nodes are the slaves. And here also we have 2, job tracker, task tracker. So the job tracker, generally we can place that on the name node, but there is no restriction that you have to place only on the name node. You can place the job tracker on some other place also, right? And generally the data is available on the data nodes. So because of that reason, the task trackers can be installed on the data nodes. So we may have the splits on different places. Here the block is different, split is different. Block is the physical storage, physical separation of the physical chunk of the data, and here the split is the logical chunk, because if the record is in the middle of that and if it reaches the boundary, then it will not stop, it will complete the record. So that is a split, that is a logical size. Okay, so the split 1, split 2, split 3, these are placed here. Because of that reason, the mapper 1 can be placed here, the mapper 2 can be placed here, mapper 3 can be placed here, so that these 3 splits can be executed and the reducers can be placed on some other machines. So this is the combining of the data map reduce and the HDFS clusters. So what are the user defined methods? What are the user defined methods in the map reduce? Actually, we have to implement each and every step, but we have the methods, we have the framework. Because of that reason, we are having the liberty to write whatever you require. That is, the user can write majorly the user can write the map phase or map method and reduce phase and reduce method. That is enough. If you are good in programming and if you are very much interested, you can handle this partitioning concept, you can handle the input, how the splits are divided and how the split will be taken and how the output will be produced, and you can also change the output format. All these are possible, but basically you have to define the map and reduce and one driver program to combine these mappers and reducers. That is only the required thing. So we can continue in the next session.